Hello everyone, welcome back to Tales of Chemistry. Today's topic is chemical properties of aliphatic amines. Aromatic amine, only aniline is in the syllabus. So all methods of preparation as well as properties of aniline together in one video I'll be uploading soon. So today let us just discuss the chemical properties of aliphatic amines. The first one, which is alkylation, needs no explanation because under Hoffman aminolysis, we have studied the same thing. You will remember in Hoffman aminolysis, we treated primary amine with alkyl halide to give us a secondary amine, RNHR plus HX, right? This itself is called alkylation of primary amine. Now you can take the secondary amine and alkylate it further. RNRH, this is the secondary amine. Treat it with RX again, you will be getting a tertiary amine, RNR plus HX. This is a tertiary amine. Now, collect the tertiary amine. You can prepare a quaternary ammonium salt also. RNR, the third R, plus RX. The lone pair of electron of nitrogen is used to bond with the new R here. So you will be getting R4N, N with a positive charge now because it has lost its lost as in the lone pair is used to form a new bond with R, and X minus will be attracted to the N plus. So this is the quaternary ammonium salt. This reaction does not require much of an explanation because you have already studied it. So the next reaction, which is very important, is acylation. Acylation, questions are possible from this acylation. All right. So in this, aliphatic primary or secondary amines react with acid chloride. So under acylation, what we are doing now is primary or secondary amines are treated with acid chloride. Actually, though we will be discussing only about acid chloride, you can take anhydrides as well as esters in the place of acid chloride. You can take anhydrides or esters also in the place of acid chloride. Now, let us take a primary amine, RNH2. So this is the primary amine. All right. Treat it with a simple acid chloride. So let me take R dash C double bond O Cl. See here, I'm not explaining the mechanism of the reaction to you. Instead, I'm just telling you how we can, in very simple way, how can we write the product here. Just remove the H and the Cl. H of amine and Cl of the acid chloride. So your product here is HCl plus. What is remaining there? RNH. That N is connected to a CO group and C has connected, or C is connected to R dash. So any compound in which you find a CONH group, okay, that is an amide. CONH, amide. All right. Now, how do we name this? whatever group is connected to the N here, all right, that is this. Whatever is connected to N, that is the substituent, or that is the alkyl group. So here it is N-alkyl. N-alkyl. Okay, and the rest is the parent. The parent here is an amide. So since we don't know what is R dash, alkan amide. So this is N-alkyl alkan amide. N-alkyl alkan amide. Let's take a specific example. CH3 NH2 methanamine. I'm treating this with CH3 C double bond O Cl. So this is acetyl chloride or eth for 2 carbon, ethanoyl, OYL, ethanoyl chloride. Okay, so methanamine is treated with ethanoyl chloride. So how did I ask you to write the product? Initially remove the HCl. So HCl is removed. Now whatever is remaining, put them together. CH3 N with a H, and on the N now C double bond O CH3. Again, while naming, search for the nitrogen. Here is your nitrogen. Whatever alkyl group is on nitrogen, name it first. N-methyl. N-methyl. The rest is the parent. Parent has 2 carbon. It is an amide. So, amide, ethanamide, yeah, N-methyl ethanamide. So this is with a primary amine. Same way, we can even take a secondary amine. Look at this, CH3N, CH3H. So this is N-methyl. N-methyl methanamide, N-methyl methanamide, N-methyl methanamide plus same acetyl or ethanoyl chloride, Cl, C double bond O, CH3. HCl is removed. So there remains CH3N, CH3, N is connected to C double bond O and CH3. Here, while naming, look for the nitrogen. Check how many groups are there on nitrogen. We have 2 groups. Both of them are methyl groups. So this is N, N, dimethyl. There are 2 methyls on nitrogen, N-methyl as well as one more N-methyl, N, N, dimethyl. The rest, that is this part, becomes the parent. Parent has 2 carbon. It is an amide. So, amide. An is for the single bond between carbons. Ethanamide. N dimethyl ethanamide. So this is called acylation. Now, point to be remembered here is, instead of acid chloride, anhydrides or esters can also be used. Now, moving on. Instead of acylation, we can slightly modify this using benzoyl chloride. In that case, it will become benzoylation. This is an extension of acylation. Benzoylation. Using C6H5COCl, which is benzoyl chloride. So reaction remains the same. Only difference is instead of acid chloride, as in instead of acyl chloride, you are using benzoyl chloride. The chloride of benzoic acid is used here. So let's try this reaction out. Let me use a primary amine, CH3NH and H. So methanamine once again treated with Cl, CO and the benzene ring C6H5. As I told you earlier, straight away remove that HCl. Yeah, remove that HCl. Okay, so HCl plus CH3NH C double bond O C6H5, which is here N-methyl. N-methyl. The rest C6H5, okay, and CO is there, right, which is called benzamide. Benzamide. You can try this with a secondary amine also. I'm leaving it to you. Yeah, write down and practice with a secondary amine. N-dimethyl benzamide will be the product. Now, I want to go back to acylation again to explain one very important point, something to add on to this. You know, this HCl, if it is not removed immediately as soon as it is formed, the reaction will go in the backward reaction. Backward reaction will happen, which means for completion of the reaction, we need to remove the HCl as soon as it is formed. To remove HCl, we use a base, something like pyridine here. Now I repeat this, the reaction, see why I have not written initially pyridine here. The reaction will take place even without pyridine. But function of pyridine is just to remove the HCl as soon as it is formed. So either write base here by chance, if you forgot the name pyridine, at least write a base here. So the function of pyridine or the base is it combines with HCl. Pyridine is a base, HCl is an acid. So in presence of pyridine, the HCl which is obtained will quickly undergo neutralization. So HCl will not remain as HCl. Short form for pyridine is PY. Okay, so in every acylation or benzoylation, presence of a base is very important. Pyridine or at least write a base. Suppose give reason question is asked, why do we need a base or pyridine precisely in acylation? Function of pyridine is to combine with HCl. Pyridine is a base, it combines with HCl. If HCl remains in the reaction will shift to the backward direction. That is all about acylation and benzoylation. The next reaction that we are studying here is very important reaction. Almost every year in the paper, this question appears, carbyl amine reaction. carbyl amine reaction. This is also called isocyanide test. Isocyanide test. This is a test for primary amines. Okay, so carbyl amine reaction is a test for primary amines. I mean, only primary amines undergo this reaction. Secondary or tertiary amines will not undergo this reaction. Let's see what the reaction is. RNH2, primary amine, treated with CHCl3, chloroform, along with alkali, potassium hydroxide. In fact, alcoholic alkali is to be taken and the reaction mixture is heated. You are taking a primary amine plus chloroform along with alcoholic alkali. The product that you get here is, look at this. Let's go logically. Potassium and chlorine together gives us KCl. Now the 3OH, and there are 3 hydrogens here. Yeah, together they will give us 3 molecules of water. Now what remains is Rn here and just a carbon here, RNC, which is the isocyanide. RNC, which is the isocyanide. So primary amine is converted to alkyl isocyanide. How is this a test then? Okay. This is taken as a test because the isocyanides have their own characteristic foul smell. A disagreeable smell will be developed when a primary amine reacts with chloroform in presence of alcoholic alkali. A foul smelling, an unpleasant smelling compound will be obtained. That is why it is considered as a test for primary amine. Secondary and tertiary amines will not react, so no foul smell will be observed. So mark this reaction as one of the important or repeatedly asked question. Let me take CH3CH2NH2, which is ethanamine. Ethanamine, under similar conditions, CHCl3 and KOH, okay, alcoholic alkali, on heating gives you CH3CH2NC plus 3KCl plus 3H2O. So as I told earlier, remove that KCl first and then water molecule. And so you will know that there remains CH3CH2N and just a carbon NCHCl3. Connect them, put them together, you will get your isocyanide, ethyl isocyanide here. Okay, or ethane isonitrile. Isonitrile is the IUPAC name, ethane isonitrile. All right. So that is the reaction called carbyl amine reaction. Point to be noted, carbyl amine reaction is only for primary amines. Moving on, now the next reaction that we need to study is reaction with nitrous acid. nitrous acid. What is nitrous acid? HNO2. That is nitrous acid, HNO2. Now, take a primary amine, aliphatic primary amine, RNH2, treat it with HNO2, nitrous acid. There is a problem. HNO2 is unstable, means you cannot prepare and store it. That also means you need to prepare HNO2 when you need it. That is, whenever you need HNO2, combine NaNO2 with HCl, sodium nitrite with HCl. Combine NaNO2 with HCl, which gives you HNO2. Now, the product of this reaction is ROH. ROH along with nitrogen. Okay. Now, ROH along with nitrogen is the product. See, the temperature is also not mentioned. You may remember, if it is an aromatic amine and if the temperature is kept 0 to 5 degree, the result here is benzene diazonium chloride. Here, it's an aliphatic amine, and aliphatic amine just requires a room temperature. No low temperature is needed, and the product that you get is an alcohol. Aliphatic amines, write this down and write and practice. Do not just read. Aromatic amines give us diazonium chloride provided the temperature is 0 to 5 degrees Celsius. But in aliphatic amines, no such reaction. Straight away, at room temperature, alcohol is the product. One example, CH3NH2. You can practice using C2H5NH2 also. This, when treated with HNO2, what you get is CH3OH along with N2, nitrogen. That is how the reaction takes place, alcohol and nitrogen. So this is an exclusive reaction of primary aliphatic amine with nitrous acid. Okay, now the last part that we are going to study today is a test for all the 3 types of amines. Test for amines. The one and only test that is mentioned in the syllabus is Hinsberg's test. Hinsberg's test. Now, in this Hinsberg's test, all the 3 amines behave differently. So, one test will help us to distinguish between a primary, secondary, as well as a tertiary amine. So first of all, let us understand what is the reagent that is used here. The reagent used is called Hinsberg's reagent. It is benzene sulfonyl chloride, benzene sulfonyl chloride. So far in ISC examination, such a question is not asked, like what is Hinsberg's reagent? Yeah, but competitive exams, there is a possibility MCQs, this question can arise: which among the following is called Hinsberg's reagent? So it is better to study that Hinsberg's reagent is benzene sulfonyl chloride. How do we write it, or what is the formula, molecular formula of benzene sulfonyl chloride? Benzene ring, or you can write C6H5 SO2 Cl. This is Hinsberg's reagent, that is C6H5SO2Cl, Hinsberg's reagent. Now, ISC point of view, you don't need to study the equation for the reaction. You just need to know the way a primary, secondary, or a tertiary amine reacts. So first of all, let us begin with a primary amine. How will a primary amine behave with benzene sulfonyl chloride? Let's take a primary amine, which is RNH2. This, when treated with C6H5SO2Cl, Cl of Hinsberg's reagent combines with H of amine, giving you HCl. Along with this, you will get C6H5SO2NHR. This is the product. Now, I've already told you this is a complicated equation. ISC does not require this equation. So, in words, how will we write it? Primary amines react with Hinsberg reagent to give a sulfonamide. This particular product is a sulfonamide. To be precise, this is N-alkyl. Okay, N-alkyl benzene sulfonamide. Now, what did we say? Primary amines react with Hinsberg reagent to give you the sulfonamide. Now, even if sulfonamide becomes difficult to remember, it gives a product which is soluble in excess of KOH. So, continuation here is that N-alkyl benzene sulfonamide is soluble in KOH solution. So how do we present our answer? Primary amines react with Hinsberg reagent to give a product which dissolves in KOH solution. It gives a product, primary amines, when treated with Hinsberg's reagent, gives a product that dissolves in potassium hydroxide solution, that dissolves in alkali solution. Similarly, how will a secondary amine behave? Secondary amines react with Hinsberg reagent. All right. So Hinsberg reagent C6H5SO2Cl and a secondary amine HNR and R. As I told you, just remove that HCl. You will get C6H5SO2 with N containing two alkyl groups. So this will be N, N dialkyl benzene sulfonamide. Now, this will not react or this will not dissolve in KOH. So, secondary amines react with Hinsberg's reagent. To give a product. What is the name of the product? Remember, if only possible, N, N dialkyl benzene sulfonamide. Yeah? Give a reagent to give a product which is insoluble in KOH solution. So, primary gave a product which dissolved in KOH. Secondary gives a product which is insoluble in KOH. And the best part with the tertiary is tertiary amines do not react at all with Hinsberg's reagent. Okay. Tertiary amines have got no reaction with Hinsberg's reagent. All right, so that is about a test to distinguish between the three types of amines. So with this, in this video, that is our part 3 video, we have completed all the chemical properties of aliphatic amines, including a test to distinguish between the three types of amines. That's all in this video. Thank you and stay tuned.